Hello, welcome. In this part, we'll be talking about factoring using the greatest common factor strategy. A greatest common factor is the largest or biggest number or expression you can divide evenly into another number or expression. And we'll see an example of this here in just a moment. So find the greatest common factor for each set of polynomials. So if we take 45, one way to do this is to write 45. And then I ask myself, will 2 go into 45? Since 45 is not even, no. But 3 will, and it goes in 15 times. And 3 goes into 15 5 times, and 5 goes into 5 1 time. So 3 times 3 times 5 is 45. What the numbers here on the right show the prime factorization of 45. It's like a factor tree, but it's takes up less space. So I've got 81. 2 won't go into 81, but 3 will, and it goes in 27 times. 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into 3 1 time. When you get to 1, you're done. 117. 2 won't go in there because it's not even, but 3 will. And 3 goes into 117 39 times. 3 goes into 39 13 times. 13 is prime, so the only thing will go into 13 is 13, and 13 goes in there 1 time. When you get to 1, you're done. So then I see, what do they have in common? They both have, or they all have, 2 3s. And so I can say that the greatest common factor is 3 times 3, or 9. So I'm going to do the same thing over here. (24) x cubed, so write 24. I'm going to put the x cubed up on top. 24, 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times, and 3 goes into 3 1 time. 56. And it has with it x7. And then see, 56, 2 goes into 56 28 times. 2 goes into 28 14 times. 2 goes into 14 7 times. And 7 will go into 7 1 time. Let's see, 4x to the 8th. So I'm going to put the x to the 8th up on top. X to the 8th. We'll consider the variables separately. 4. Now 2 will go into 4 2 times. 2 times 2 is 4. And then 2 goes into 2 one time, and we're done. The prime factors of 4 are 2 times 2. And then finally we got 12 x squared, and 2 will go into 12 6 times, 2 goes into 6 3 times, and 3 goes into 3 1 time. So then I say, what do they have in common? Well, they all have 2 2s. And that's it. For the variables, this is the point I stopped and told a little story about 3 friends that went out for pizza. And one of the friends had $2. They decided that they were all going to contribute the same amount because that's just fair. And one of the friends had $2. One friend had $5. And the other friend had $10. So the question is, how much is each person going to contribute? And the answer is $2, because that's all that the first friend has. He can't contribute 5 because he only has 2. Now, in terms of the greatest common factor, that same thing applies. You can only contribute what the smallest amount has. So, like 4 has 2 2s, and I can contribute both of those 2s. They all have that in common. In terms of x's, I'm going to circle x squared because that's the smallest amount that we have. And so the greatest common factor is 2 times 2, which is 4, and then the x squared as well, so it's 4x squared. And then so what does it mean to factor? That answer should have been given in the other video. It means to write a number or expression as a product of the factors. So we're going to do that here in example 3. I'm going to say 15x cubed. 15 is 3 times 5 times x cubed minus 9x to the 5th y. 9 is 3 times 3. And x to the 5th I'm going to separate out. X to the 3rd power times x squared, and then times y. Now I separated it so that I can circle x cubed that I see on the other side. So I see that they both have a 3 in common. And they both have this x cubed. And so I write 3 times x cubed. That's the greatest common factor that we factored out. Then I put parentheses here, and I say what is left in this first term. 5. So I put a 5 here. Minus what's left on the second term. 3x squared y. So I put 3x squared y. And that's what this thing looks like when it's factored. In the next example, I'm going to rewrite 12z to the 5th as 3 times 4 times z to the 5th. Okay, scratch that. I'm actually going to take and break it down even further than that. 12 is 3 times 4, but 4 is 2 times 2, so I'm going to write it as 2 times 2 times 3, and that's 12. Z to the 5th I'm going to break down to z squared times z to the 3rd power, plus 36 is 4 times 9. And 4 is 2 times 2. And 9 is 3 times 3. And z squared. I'm going to use a highlighter this time to highlight which ones they have in common. So I see they have 2 times 2 times 3 and z squared. 2 times 2 times 3 and z squared. And then I say 2 times 2 times 3 is 12 and z squared times whatever's left. Now what's left here is z cubed plus over here I've got 3, and then that would be factored. On this next problem, I've got I got to factor out a negative. It says here if the leading coefficient is negative, factor out a negative. If the polynomial cannot be factored, write prime. So since the leading coefficient is negative, I'm going to write -1. And then I look at the variables. They don't have anything else in common for the numbers. The coefficients, 8, -2, and this the leading coefficient is like -1. That's the highest number they have in common, is -1. But then for the variables, I've got 6 A's right here, 3 A's here, and 2 A's here. So the highest number, the lowest number of A's that they have is 2, that they all have in common. So I'm going to take out A squared. And then this one has 4 B's, this one has 7 B's, and the last one has 5 B's. And so they all have at least 4 B's. I'm going to take out B to the 4th. And then I open up the parentheses and I say, okay, I took out the -1, so that leaves a positive first term. 2 of the 6 A's leaves A to the 4th. And I took out all of the B's, so there's no B's in that term. And then taking a -1 out of +8 leaves -8. And another way to think about that is a -1 times a -8 is +8, and that's what we're looking for. So then I've got A cubed, that's 3 A's, and I took out 2, so there's 1 A left. 7 B's, took out 4, I'm left with 3 B's, B to the 3rd power. And then plus 2, because -1 times a +2 would give me the -2 that I started with. I took out both A's, and it's B to the 5th, taking out B to the 4th leaves just 1 B. And that's what that looks like factored. Over here, this one's a little simpler example, 4x plus x squared. 4x is 4 times x, and I could break it down into 2 times 2, but there's no other numbers on the second term, so I'm not going to bother. I've got 4 times x plus x squared, which is x times x. And they have both in common an x. So I take out the x, and I write parentheses, and I put 4 plus x. One thing to notice that inside the parentheses here I have 2 terms, 4 and x. And up when I started, I had 4x plus x squared. That's 2 terms. So if you start with 2 terms, you're going to have 2 terms inside. Up here, I had 3 terms in example 5, and I had 3 terms inside the parentheses when I was finished factoring. So that's one thing that you'll find happens. And then the last couple examples: 7x to the 5th, 12y squared, and -19d cubed. 7 is prime, so the only factors it has is 7 and 1. And it doesn't share any factors with 12 or negative 19. There's no 7 or 1 in 12. There's no 7 or 1 in 19. And for the variables, I look at x to the 5th. This one doesn't have any x's. Neither does the third have any x's. So they don't share any variables. They don't share any common factors other than 1. And so when that happens, we say that this polynomial is prime. And it means it can't be factored any more than it already is. So I've got y squared minus 2y, very similar to the problem up above. Y squared is y times y, minus 2y, which is 2 times y. And I see that they both have a y in common. So I take out the y, and I'm left with y minus 2. And that is how this is factored.